Our dynamic story application takes a phrase from classic nursery rhyme and allows us to add a modern twist on it by giving the user the ability to change that phrase. The familiar phrase, "a cow jumped over the moon," can now change to "a dolphin jumped over the moon" with a simple selection in the picker view. This application requires two UI elements, a label and a picker view. Changing the text of the label to the text of the story is as simple as accessing the .text attribute from the UI label. Implementing the other UI element, the picker view, requires an object to implement the data source and delegate protocol. Within this application, the application's view controller acts as this object by conforming to both of these protocols. For the data source protocol, the required functions number of components in picker view and picker view number of rows in components is implemented. For the delegate protocol, the function PickerView title for row is implemented in order to give the PickerView text for each row to display. And the function PickerView didSelectRow is implemented in order to respond to a change in rows in the PickerView. Finally, the PickerView is told to the two protocols and the view did load. To begin the dynamic story application, begin by creating a single view application and naming the project Dynamic Story. In order to be more clear, straightforward, and not cryptic with the class names in this project, delete the existing view controller that was created for the project and create a new one titled Dynamic Story View Controller. To do this, go up to the menu bar, click File, select New, File, Cocoa Touch Class, and now click Next. Verify that the new file is a subclass of UI View Controller. If it is not, simply add UI View Controller to this text box and name the class Dynamic Story View Controller. Click Next and save the file within the project to create the new file. Now that the new view controller has been created, delete the existing view controller by right-clicking the name on the left-hand side, clicking Delete, then the Move to Trash option. Since the view controller on the storyboard currently depends on the file that was just deleted, go to the main storyboard and select the only view controller that is present. Show the identity inspector on the right-hand side and change the custom class's class to Dynamic Story View Controller. If everything was done correctly along the way, Xcode will autocomplete the string within this text box. While the main storyboard is visible, add the UI elements to the view. Make sure the object library is shown on the Utilities pane on the right, and search for the word Picker within the text box at the bottom. Select PickerView by clicking and dragging this element onto the view at the very bottom. Apply auto layout constraints by pinning the PickerView to the bottom. Clicking the PickerView again, apply an auto layout constraint to the leading edge. And now to apply the auto layout constraint to the trailing edge, click the PickerView again and pin it to the trailing edge. A constraint for the height or the top of the view is not required due to the fact that the height of the picker view is predetermined. Pay close attention how the picker view already appears to have selectable elements. The key word is appears. When the project is built and run, these elements will not appear in the simulator or on a device, and their only purpose is to visually represent the UI element, to give a sense of space when laying out other UI elements. Now that the picker view is in place, search for the word label in the text box at the bottom of the object library. Select the only element that appears and drag it onto the storyboard in the middle. Apply auto layout constraints by constraining the label to the center of the container. To do this, hold Ctrl and click the label and drag out horizontally and release the click. Select Center Vertically in Container. Hold Ctrl and click the label again, but this time drag out vertically from the label and release the click. Select Center Horizontally in Container. Now that the auto layout constraints have been applied, the Utilities pane is no longer required for the rest of the project, so hide the pane by clicking this button in the top right to free up some much needed real estate. Putting that real estate to good use, bring up the Assistant Editor to the Dynamic Story View Controller.swift file. If the Assistant Editor is set to automatic, this file will be automatically brought up for you. If not, manually select the file by selecting Manual, and following the folder path to the file. Once this has been performed, clean up the dynamic story view controller.swift file by first deleting all the automatic comments that were created, and then the method did receive memory warning. Now, create IB outlets for the UI elements that were just put on the storyboard. Begin this by holding Control and clicking PickerView and dragging the blue line that appears to the dynamic story view controller.swift file. Release the mouse when the line is above view did load and enter story picker for the name, IB outlet for the connection, type UIPickerView, storage weak, and click connect. Repeat this for the label, but change the name to story label. After this has been complete, go back to the standard editor and click dynamic story view controller.swift file. The main storyboard will not be used for the rest of the project. The picker view requires data to populate it, so declare a constant string array, or let, and name the array story picker data and populate the array with string values. A UI picker view requires a data source and a delegate. The data source provides the picker view with the information regarding the number of rows and components, while the delegate provides the picker view with the view's contents for the rows, the height, the width, and the row titles. In this project, the view controller, dynamic story view controller, will act as the data source and the delegate for the picker view. This does not always have to be the case, but it makes the code straightforward and easy to follow. To make our dynamic story view controller class also the data source, this class needs to conform to the UIPickerView data source protocol. In order to conform to these rules, two methods have to be implemented in the class. First function is number of components in PickerView, and the second function, PickerView number of rows in component. Begin by adding the protocol next to the superclass near the top of the file. This protocol is UIPickerView data source. This will initially create an error that says the class does not conform to the protocol. This is because the required functions have yet to be implemented. To implement these functions, go below viewDidLoad and begin to type number of components in PickerView, and Xcode will autocomplete this function declaration for you. All you have to do is press enter. This function lets you specify the amount of components that the PickerView will have. In PickerView terms, a component is a column within that view. You can have multiple columns within a PickerView, which allows multiple things to be chosen without the need for more than one PickerView. Within that function, simply return the integer 1, because only a single component is needed for the final application. To fully conform to these rules of this protocol, however, begin to type PickerView and select the function declaration for number of rows in component. This function returns the amount of rows in each component. For the case of this project, this function should return the amount of strings within story picker data. To do this, type out return, the variable story picker data, and put a .count. This story picker data .count returns the amount of items within the array. Doing this will allow the dynamic story view controller class to fully conform to the UIPickerView data source protocol, which means that the story picker can now use this class as its data source. To tell the story picker that this class will be its data source, go to the viewDidLoad and add storypicker.dataSource is equal to self. To make the dynamic story view controller class also the delegate, this class needs to conform to the UIPickerView delegate protocol. In order for the application to be usable in this context, two functions have to be implemented. The first function, PickerView title for row, is called when the PickerView needs a title to display on a row. And the second function, PickerView did select row, is called when the user selects a row. Within the class dynamic story view controller, next to the UIPickerView data source protocol, near the superclass at the top, add the protocol for the delegate, which is UIPickerView delegate. Go below the current functions in dynamic story view controller and begin to type PickerView, Xcode will try to autocomplete what is being typed, and from what appears, select title for row. This function should return a string that will be displayed on the picker view as a choice that the user can select. For this application, this function will return a string from StoryPicker data array corresponding to the location of row. To do this, return StoryPicker data and access the element at location row. Row is passed into the function and identifies the row in the picker view. Now that title for row is implemented, implement PickerView did select row by beginning to type PickerView below the function PickerView title for row and selecting PickerView did select row. Within this function at this time, set the text of story label to high as a placeholder for what will be done in a minute. To tell the story picker that this class will be its delegate, go to the viewDidLoad and add StoryPicker.delegate is equal to self. Building and running this application shows that the picker view is completely functioning, and changing the value in the picker view changes the text of the label to high. Now to add the functionality to the application by adding the story to the label. This has two parts to it. Part 1 is what piece of data from PickerView data variable should be displayed first within the story. Part 2, setting the text of the label. Part 1 has a fairly easy solution. Define another constant at the top of the page, but call this one StoryPicker start index, and assign it to the value of 2. 2 is the location of the string cow within the PickerView data array. Part 2 is within viewDidLoad. Access the text from the story label and make it equal to the story. But using string interpolation, access the value of StoryPicker data at StoryPicker start index. This will set the text of the label to the story when the app begins. Inside PickerView did select row, create a string with the story inside of it. This time though, instead of using StoryPicker start index for the element to pull out of the array, use the row that the user selected, which is passed into the function as row. At the end of this function, assign the story to the text of the label. Currently, all elements exist that this application can be built and ran and it would work, but there would be one small hiccup. When the application is initially viewed, notice how the picker view has human selected instead of the string that the story displays, which is cow. This is because PickerView's default selected element is its first. To change this, go to viewDidLoad and call the selected row function from StoryPicker. Set the PickerView's selected row as the StoryPicker start index and the 0th component and animation set to false. Build and run the application, and congratulations, the final app has been created.